once again, this video is going to be a look at a homework problem. So this is number 17 from section 6.2. If you haven't had a chance to look at that yet, go look at it. It does use the result from chapter 16, so make sure you've looked at question number 16 first. And if you get stuck on question 16, that was the previous video, so we worked through that together there. Okay, so what we learned in question 16 was that if we had a periodic function and the period was capital T, that we could just integrate from 0 to t. We could integrate over one period, the same thing that we usually integrate from 0 to infinity. So our function times e to the negative st. Okay? And then we just multiply that by the reciprocal of 1 minus e to the negative period times s. Kind of cool. I'll just point out, s here cannot be 0. If s was equal to 0, this would be 1 minus 1 on the bottom, and we know we can't have that. So let's just make a note, s isn't 0. Okay, now on question 17, we're given this wave function. It's a square wave. It's defined so that over the interval starting at an even integer like 0 and going to an odd integer like 1, over that interval the function is defined to be 1. Then at the odd integers we jump down to a value of negative 1, and over the interval until we hit the next even integer rather, we're down at negative 1 when we jump back up to 1. And it's always at the left end point, we have a point. At the right end point of each interval, we have a hole. That's where the jump takes place. Okay, so this is a periodic function, and the period here would just be 2. One positive line, one negative line segment. That gives me the entire square wave. So I'm going to just use this formula now on this square wave function. So I'm going to be able to say this is 1 over 1 minus e to the negative 2 times s, and then the integral from 0 to 2 of this square wave times e to the negative st dt. Now, if I'm integrating from 0 to 2, I really want to break that up into two pieces. From 0 to 1, I'm going to be integrating 1 times e to the negative st, and from 1 to 2, I'll be integrating negative 1 times e to the negative st. And when I have a situation like this where there's a hole at the end, integrating the function 1 from 0 to 1 is still correct. Basically, I'd be taking the limit as we approach 1 because my function is not continuous there. But I get the same thing as if it were defined and equal to 1 there, and as this were defined and equal to negative 1 here. So I'm going to say this is 1 over 1 minus e to the negative 2s. I'm just going to break this up into two integrals. From 0 to 1, where my wave function is just 1 times e to the negative st dt, plus the integral from 1 to 2, where my wave function is just negative 1, and then that's times e to the negative st dt. I think I'll bump that negative sign outside and just turn that into a difference of integrals. Looks like for both of these integrals, I can do the same u sub. Let's let u equal negative st, then du will be negative s dt. So in order to integrate, I'm going to want to introduce a negative s in both integrals, which I'll counterbalance with a negative 1 over s on the outside. I'm going to go ahead and actually write that all the way in front. That way it distributes to each one of these integrals. So what I have then is 1 over 1 minus e to the negative 2s times a negative 1 over s times, let's see, rewriting this in terms of u, the u value at 0 is just going to be 0 times t, so that's just going to be 0. The u value at 1 times negative s, I'm plugging in 0 and 1 for t. So at 0, I got 0 times negative s. Now I'm getting 1 times negative s, so I'm going to negative s. And it was just e to the u du. Minus the integral from the u value at 1 is negative s to the u value at 2 is negative 2s. Again, e to the u du. Okay, so that's going to be negative 1 over 1 minus e to the negative 2s times s, just sort of combining those into one fraction, times, we're going to get e to the u evaluated between negative s and 0, minus e to the u evaluated between negative 2s and negative s. Okay, so let's clear some space. So I'm just going to copy this first factor here. I've got a negative 1 over 1 minus e to the negative 2s times s. And then let's see, we're evaluating this. So it's going to be e to the negative s minus e to the 0 is 1. And then minus e to the negative 2s minus e to the negative s. Okay, let's just simplify this bit. So that's e to the negative s minus 1 minus e to the negative 2s minus a negative, so plus e to the negative s. So that's negative e to the negative 2s. I can combine these guys, plus 2e to the negative s minus 1. Now I think what I'm going to do, because this whole thing is getting multiplied by this fraction, I'm just going to distribute that negative 1 to each of these pieces on top. So that's going to make it positive e to the negative 2s minus 2e to the negative s plus 1 over 1 minus e to the negative 2s times s. Now, that is a correct answer. We plugged into our formula and we simplified things. Turns out this can be simplified a little bit more, okay? So I just want to remember that e to the negative 2s is the same as e to the negative s squared. Because remember, when you have a power to a power, you would just multiply the powers. So I can actually factor the top and the bottom here. The top is e to the negative s and e to the negative s. That's going to give me my e to the negative s squared. Looks like a minus 1 and a minus 1. That way if I FOIL it out, I get my minus 2e to the negative s and my plus 1. This is actually a difference of 2 squares. That's going to be 1 minus e to the negative s times 1 plus e to the negative s. And then I still have that factor of s on the bottom. Now, this 1 minus e to the negative s is exactly the opposite of e to the negative s minus 1. So if I cancel, that's just going to leave me with a negative sign there. And I can just distribute this. When I distribute the negative 1, that makes this 1 on top positive minus e to the negative s over 1 plus e to the negative s times s. And I believe that's the version of the answer that's given in the back of your book. If you get to this point, you're like, wait, where are the 2's? The period is 2. It's just that you can factor and cancel if you remember that e to the negative 2s is actually e to the negative s squared.